guys, it's Mrs. Seitz. Today what we're going to be working on is representations as functions. So again, we're going to be building on this idea of a function rule. And a function rule is an equation that describes a relationship between our inputs, which remember are independent variables. And remember, our inputs are our x's, and our outputs are dependent variables, which are kind of like our y's. Okay, so again, our inputs are like our x's, and our outputs are our y's. So you can kind of think as this being like our function machine, right? You're going to put in whatever you want in for x, but it has to follow a rule. So like for example, in this one, if we put in -2 and we have to follow this rule that we're multiplying by 3, so 3 times -2, we're following the rule that you're multiplying by 3, so you have to get that output value of -6 to follow this rule of the function. We're going to practice today writing these function rules as well. So to write a function rule, we know that an output means that we have a y. In math, the word is means equals. And then we're going to use the rest of it to help us using some math symbols to help us to write the rest of the function rule. So it says to write a function rule for the output is 5 less than the input. So the output is, so I see 5, I see another key phrase of less than, and then I see input, which I know is x, okay? But I remembered from earlier this year that when we talked about less than, that you have to be really careful of your order. So when I talk about less than, it's kind of like you have to kind of flip-flop the order, okay? So I know there's going to be a 5 and I know there's going to be an x, but we actually have to start with the x and then take away the 5. So for this one, the function rule is going to be y equals x minus 5. So the output is 5 less than the input, so you have to start with the input and then take away the 5. For the next one, it says the output is the square of the input. So the output, y, is equals, now the square, we'll talk about that in a second, but the input I know is x, okay? And we talk about squaring, that we kind of did a problem like that in our activity today. So when you square something, that's meaning you multiply it by itself or you raise it to an exponent of 2. So x times x, or to the second power. So our answer for this one would be y equals x squared. Okay, another thing that you might be asked to do is to evaluate a function. The word evaluate means just basically plug it in. Okay, so if I have the function rule, which is y equals 2x plus 5, I need to evaluate the function when the input, or the x, equals 3. So all I'm going to do is plug in the x value when x equals 3 to figure out what the output, or the y value, is. So again, a lot of this sounds like the same things that we've been learning, except we have new vocabulary. Follow the order of operations. 2 times 3 first to give you 6, and 6 plus 5 to give you your answer, which will be 11. Okay, if we were writing our answer as an ordered pair, the input is 3, the output 11. Okay, let's try it for the next one. When the function rule is y equals 2x plus 5, and we have an input of -10. Y equals 2x plus 5, and we're plugging in -10 in for the input, or x. So 2 times -10, which will give me -20, and -20 plus 5, which will give me -15. So again, if I wanted to write it as an ordered pair, the x value is -10, and the y value is -15. Okay, here's a chance for you guys to take care of that. So we're going to write a function rule for the output is 1/4 of the input. Then for the problems 2, 3, and 4, you're going to be finding the value of y when the x value is 5 for each one of those. So take some time right now and figure those out, and then you're going to write your answers into Edpuzzle. All right, let's see if you're correct. So if you take a look at the first one, to write a function rule for the output is 1/4 of the input, your answer would be y equals 1/4 x. Because again, output is y, is in math means equals, and then we see the word 1/4. Of in math means to multiply, and input is x. So y equals 1/4 times x, or y equals 1/4 x. For your answers for 2, 3, and 4, so if I have y equals 4x minus 1 and I'm plugging in 5, I'm going to do 4 times 5 minus 1. So 4 times 5 is 20. 20 minus 1. So your y value would be 19. And if you wanted to write it as an ordered pair, 5, 19. Okay, how about for number 3? Y equals 10 times 5. So again, the y value would be 50. And if you wrote it as an ordered pair, 550. And then for number 4, y equals 7 minus 3. And then we're evaluating it at 5. So if I follow the order of operations, 7 minus 15, that would give us 7 minus 15 is -8. And then 5, -8. So hopefully you did pretty well on those ones. All right, the last thing you're going to do, and you can remember this, that from our activity today, another way that you can represent a function is through a graph. So we are going to be graphing the function y equals -2x plus 1 using the inputs of -1, 0, 1, and 2. So let's see what those values are. So I am going to create a little table. Remember those XY tables? All right. If I have -1, 0, 1, and 2, and again, for those of you guys that know how to use the table button on your calculator, this is a guaranteed way that you can get the right answers. All right. I'm going to do -2 times -1 plus 1. Get that answer. So that would be what? 2 plus 1 to give me 3. I'm going to do -2 times 0 plus 1, which is going to give me 1. -2 times 1 plus 1. Let's see, that's going to give me, -2 plus 1. And then if I do -2 times 2, which is -4, and -4 plus 1, -3. Okay? And again, when I start plotting those points, you can see -1 with +3, 0 with 1, 1 with -1, and 2 with -3. Okay? And we've used the inputs that are given to us at -1, 0, 1, and 2. Okay? And so this would be the function that we have. Let's draw the line. And you can see that there's our function of y equals -2x plus 1. And if we check it using slope-intercept form, we have an intercept of 1, and it's going down 2 and to the right 1. So it passes our test like before. All right, I want you guys to graph these ones, and you can use, like we've done in the past, like with slope-intercept form, to make sure that you guys are good with graphing. But again, sounds like a blast from your past, because it is. We're just using different vocabulary. So right now, guys, you may graph using any method that you'd like, but graph each one of these on your own questions. So let's see how you did. Okay, with a slope of 1 and a y-intercept of 1, here's what your graph looks like. So here's number 5. For question number 6, you have a slope of -3 and a y-intercept of 0. So you would start out at 0, and you would go down 1, 2, 3, and then to the right 1. 1, 2, 3, and then to the right 1. And again, you could always use the table button to confirm the points and plot the points that way if you wished. Okay, but here's what your graph would look like for y equals -3x. And then for the next one, your slope is 3 and your y-intercept is 2. So again, you start out at 2 on the y-axis, and you'd go up 1, 2, 3, right 1. And we could do it again, 1, 2, 3, right 1. And here's what your line looks like for this function of y equals 3x plus 2. So hopefully you guys got the right answer on question number 7. All right, for the last part of today's lesson, we're going to actually put these to some real world problems as well. In this one, it says the number of pounds P of carbon dioxide produced by a car is 20 times the number of gallons G of gasoline used by the car. You're going to write and graph a function that describes the relationship between G and P. Okay, so on this one here, let's underline some important details. The number of pounds P of carbon dioxide produced by a car, so that's important. I see the word is. I'm going to circle that. 20 times the number of gallons G of gasoline used by the car. Okay, so here's what I see so far, just going in order with that. The number of pounds of carbon dioxide produced by the car is, so remember, is equals 20 times the number of gallons G gasoline used by the car. Okay, now if you don't like to see the variables change in the problem, make it what you're used to with x's and y's for right now, because we can always switch them back. Okay, but for right now, I'm going to label the x and y axis with things that we know. Okay, so in this, P stands for the number of pounds of carbon dioxide, and that is what? The y-axis in our problem. So that is going to be carbon dioxide. Okay, and then G is going to be for our gasoline, which we changed into X. Okay, so that is gasoline. Okay, so gallons of gas. Okay, so we're going to graph this. Okay, so that means for what I'm going to be doing here, I have a slope of 20 and I have a y-intercept of 0. So if you think about what we're going to do here, we're going to start out at 0 and we would be going up 20 and then to the right 1. So it probably makes sense for us to change our y-axis to go by 20s. So it's super easy for us to graph. So I'm going to label our y-axis by 20s. So 20, 40, 60, 80. And we're going to keep our x-axis as 1s because we're going to go over 1 unit every single time. All right, so let's do that. We're going to go up 20, right 1. Up 20, right 1. Up 20, right 1. And here is our graph. Okay, so we wrote and graphed a function that described the relationship between the gasoline and the pounds of carbon dioxide. So what that would mean is that you're starting out with 0 pounds of carbon dioxide and that you would be getting, 20 pounds of carbon dioxide per gallon of gasoline. So remember, anytime we're using a slope, we're talking about using the word per. And then because it's a unit rate, and when we're talking about the y-intercept, we use starts with. So we start out with 0 pounds of carbon dioxide, and then we go 20 pounds per gallon of gasoline. All right, the last one for today's lesson is the last on your own question. So the cost of admission for a student is 4 less than the cost of admission for adults. The first thing that you have to do is to write a function that relates the cost of admission for a student S with the cost of admission for an adult A. Okay, so the variables in the problem are S and A for right now. You can switch them to X and Y if you want to for now, but you can also switch them back for your final answer. All right, let's see how you did. Okay, so when I take a look at this one, okay, we can see that in this problem, the key word is. So the cost of a student is, I see that keyword also of less than, and I see that we have student admission and adult admission. Okay, let's see how we're defining everything. So it says here, student admission is S. So S is equals. I see less than, so I know I have to worry about the order. And adult admission is A. Okay, so S equals A minus 4 because we want to start with the adult admission and take away $4 from it. Okay, because remember it's a less than. Okay, so that would be our answer for part A. S equals your adult admission, take away $4. Okay. Now for part B, it says what's the cost of admission for a student when the cost of admission for an adult is $7.50. Well, we're going to start with the student, and we know the adult is $7.50. So that means A is $7.50. Do $7.50 minus 4. Okay, that answer would be $3.50. All right, and then finally for part C, it says, what's the cost of admission for an adult when the cost of admission for a student is $2? Okay, so if we make it go back up here to the function rule, this time we're saying that the student is $2. So 2 goes in for S. We want to see what the adult is. So we have to solve this equation. So to get A by itself, we're going to add 4 to both sides. And that would mean that the cost of admission for an adult would be $6. All right, so guys, to sum up everything that you learned for this lesson, we're representing functions in a bunch of different ways. We have function rules, which is basically writing an equation. We can see functions written through graphs. We can see functions that are written through equations and evaluated through them. We can also see them written through tables as well. So there's a lot of things that we learned in today's lesson, but the most important thing is when you're talking about a function, we're still applying that idea that a function is every input has its own output.